Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to be talking about expressions and formulas. And before we talk about expressions and formulas, it is very important for me to explain to you what exponents or powers are, okay? A lot of us have seen this throughout our mathematical histories, but what happens is we just don't have a proper knowledge of it. So when you see something like this, and you see a large number here, the 2, okay, this 2 right here, and it is being raised to this third power, that's exactly what's happening. 2 is the base, and 3 is the exponent or power, okay? If I have 2 to the third power, what that tells you, it tells the reader, hey man, or young lady, how many times to multiply the base by itself. So since I have 2 cubed here, guys, this tells you you're going to multiply 2 times itself 3 times, hence giving you 2 times 2 times 2, which is 8. Please don't make the mistake of doing 2 times 3. Okay? It happens a lot. It's okay. It happens, but don't do it. Try to avoid that. The exponent tells the reader how many times to multiply the base times itself. Okay? When we're reading exponents, you always read exponents as follows. It's the base to the blank power. So for example, base of 3, exponent of 4 is read as 3 to the 4th power. There are 2 exceptions. When the power is 2, it is normally called squared, and when the power is 3, it is normally called cubed. You are not wrong if you say, for example, here, I have 4 with an exponent of 2. You're not wrong saying 4 to the 2nd power. You're not. But you're rarely going to see that, okay, on tests and quizzes and SATs and standardized tests. You're going to see it like this, 4 squared. I have 8 with a power of 3. You could say 8 to the 3rd power, absolutely, but you're rarely going to see it. You're going to see 8 cubed. Does that make sense, my brothers? Awesome. Thank you, gentlemen. Okay, simplifying exponents. 10 to the 7th power. A lot of people get stressed out. They're like, oh my God, I got to multiply 10 7 times. No. A little trick for powers of 10. 7 tells you how many zeros there are going to be. So 10 to the 7th power is a 1 with 1, 2, 3, 4, 5, 6, 7 zeros. Then 1, 2, 3, comma, 1, 2, 3, comma. That's 10 million. A lot easier than multiplying 10 times itself 7 times. You're going to get lost there. Yes, sir? Is there any shortcuts? There are no other shortcuts other than for the 10. I'm sorry. If there is, though, I promise you I will tell you, okay? B, 3 to the 4th power. That's 3 times 3 times 3 times 3, which is 81. 2/3 to the 3rd power, 2/3 cubed. Well, that's 2/3 times 2/3 times 2/3. When we multiply fractions, please remember, gentlemen, you multiply the numerators together and then the denominators together. So 2 times 2 is 4 times 2 is 8. And 3 cubed is 3 times 3, which is 9 times 3, which is, thank you, my brother, 27. Excellent, sir. Excellent. 0.2 squared. Don't be scared of the decimals. This is 0.2 times 0.2. Don't forget the basic stuff, guys. You're going to multiply this as normal. Pretend that the decimal doesn't even exist right now at this second when you're calculating decimals. 2 times 2 is 4. However, I've got 1 and 2 decimal places that I must account for. So I start at the far right, and I go to the left that many places. So I go 1, 2 to the left, giving me 0.04. Okay? Now let's work with some negatives here. When I have negative 3 squared, please remember, guys, that the exponent is only affecting the number or variable immediately to its left. So this power of 2 is really affecting only the 3. Now some may say, wait, what happened to that negative? So it just disappears? No, it's very, very important. What this really states is it's a negative 1 times 3 squared. So what's happening here is this is negative 1 times 3, which is going to be negative 9. The power, the exponent, only affects the number or variable immediately to its left. Also, the exponent, not only does it only affect the number or variable immediately to its left, but it affects everything inside of the parentheses. So it's going to affect now the whole entire -3. Do you guys see the huge difference there, guys? Okay, thank you. So what this means is it's -3 times -3, which is +9. Huge difference. Okay? With this guy, what is the power of 4 affecting, guys? Is it affecting the -3, or the 3? Just the 3, my brothers. So this is a -1 times 3 times 3 times 3 times 3, which is -81. Now here, in this case, I've got a -1 times -3 raised to the 4th power. So times a -3 times a -3 times a -3 times a -3. Little trick for you. Do you guys see how you have an odd number of negatives being multiplied? Right? There's 5 negatives being multiplied, right? Whenever you have an odd number of negatives being multiplied, the answer will be negative. When you have an even number of negatives being multiplied, the answer will be positive. Always remember that because it's a lot easier. Okay, I know right off the bat that's going to be a negative answer. It's going to be 3 times 3 is 9 times 3, 27 times 3. So this is going to be -81. Remember that. If there's an even number of negatives, the answer will be positive, my brothers. If there's an odd number of negatives, the answer will be negative, my brothers. Does that make sense, guys? Okay. Awesome. May I continue? Thank you, gentlemen. Order of operations. Please excuse my dear Aunt Sally. Very important, my friends. Very important, so please pay attention. Please, parentheses. Perform any operations inside of grouping symbols. That includes parentheses straight up. These guys are called brackets. These guys are called braces. And this is an absolute value. All of those are operations, are symbols. One little exception here. Whenever you're working, let's say you have an expression in the numerator and in the denominator, always, for example, let's say you have whatever, 5 plus 8 over whatever, 7 minus 2. Technically, that's not a parenthesis. However, you always take care of the numerator first. So the division bar is not a parenthesis, but it does separate a numerator and denominator of operations. So you always do that numerator operation first. Okay? So please, P, parentheses. E, excuse, exponents. You're going to simplify any powers or exponents second. My dear, multiply and divide in order from left to right. I don't care which one comes first, my brothers. If you see multiplication come first, you multiply. If you see division come first, you divide. But you're going to multiply and divide in order from left to right after you've completed your exponents. And then last but not least, gentlemen, it is add and subtract. Again, in order from left to right. I don't care if you have addition first or subtraction first. You're going to add and subtract in order from left to right. So parentheses, exponents, multiply and divide in order from left to right, add and subtract in order from left to right. And that is the order of operations. Cool beans? Thank you, gentlemen. So let's practice a little bit. Okay. First thing here, I've got parentheses. So watch how I do this, guys. I'm very meticulous about this because my brain, I love to make mistakes. I don't know why. It's like I'm programmed to make mistakes. Whenever I start rushing, I make mistakes hands down. I've been doing this for a long time. And whenever I think, oh yeah, I got this. I don't need to show the kids the steps. That's when I mess up. And then I have my students saying, sir, you made a mistake there. So let's not make mistakes like me. Let's be better than me. So let's focus on this, okay? So I have parentheses. So 6 minus 2, see how I'm showing myself? I'm showing myself, hey, that's 4. That's it. I'm done with the parentheses. Now I've got an exponent. 4 squared is 16. Now multiply, divide, 8. Done. Number 2, 5 times 7 minus 4 squared divided by 2. You need to first attack the exponent. So this is 5 times 7 minus 16 divided by 2. Now you go multiply and divide in order from left to right. So I've got 35 minus 8. A lot of people sometimes do 35 minus 16 and then they divide by 2. That's wrong. And then 35 minus 8 is 27, gentlemen. This is what I was talking about as far as the division bar. 2 to the 4th minus 1. I'm going to first take care of all of this. So 2 to the 4th, 2, 4, 8, 16, minus 1 is 15. Divided by 5, 3. 5 minus 2 cubed divided by 3. I'm going to do my parentheses first. 5 minus 2 is 3 cubed divided by 3. Now, sometimes people ask me, Mr. Moore, why is it that you put this parentheses here? Let me explain why, guys. Let's say that that answer was a negative 3. Would this have been correct? No. Because doesn't the negative 3, isn't that what's being affected? So be careful with that, guys. Always encapsulate your answers from a parenthesis in another parenthesis with the next operation. It's going to make your life a lot easier. 3 cubed is 27. Divided by 3 is 9. Okay? Now, we got a lot to do today, but I'm just going to show you real quick. This more practice. If you can see, guys, this is a great website. It's called kudasoftware.com. Okay? kudasoftware.com. And not only does it give you PDFs for practice, but it gives you the answers. Okay? So that doesn't mean, oh great, I can just cheat. No, that means you can practice and you will have answers in addition to what we may do. Okay? So please remember that CUDA software. You can look that up for a lot of different types of subjects as well. Okay? Okay. Real quick. Okay, guys. Now that we've talked about order of operations, we can now continue with our skills and learn how to evaluate expressions and formulas. When we are evaluating expressions and formulas, you are literally going to be given variables and numbers in an expression, okay, with operation signs. They are going to tell you what the value of the variables are. So you literally plug in the values for those variables and use the order of operations and you solve. It's literally that simple. So for this bad boy right here, what is the value of the expression for x equals 5 and y equals 2? Every time you see an x, you're going to replace it with 5. Every time you see a y, you're going to replace it with 2. So I got 5 squared plus 5 minus 12 divided by 2 squared. Order of operations. 5 squared is 25 plus 5 minus 12 divided by 4. Very tempting for people to go, oh, 25 plus 5 and then minus 12 and then divide it all by 4. No, please be careful with that. This is 25 plus 5 minus 3 because 12 divided by 4 is 3. And now 25 plus 5 is 30 minus 3 is 27. Does that make sense, my brothers? Promise? Okay, thank you, gentlemen. Here, 3 times x, which is 5, minus y, which is 2 squared. So this is 3 times 5 minus 4, which is 15, minus 4, which is 11. Okay, if I want to find the value of xy squared for when x is 5 and y is 2, and I want to compare the results with xy in parentheses squared. Well, xy squared is literally 5 times 2 squared, which is 5, times 4, which is 20. In parentheses, xy with everything being squared, it's 5 times 2 squared, which is 10 squared, which is 100. Please be cognizant, aware of where those exponents are. Please be cognizant, aware of what base the exponent is affecting. In the green example here, the 2 was affecting the y value. The power of 2 was affecting the y value of 2, not the 5. Okay? Remember that exponents will affect immediately what's to its left and or everything inside of parentheses. You good, my man? I'm sorry? Okay, oh, you mean the exponent of 2? Okay, so what he's saying is this. So what if I had it like this? Like that? It would be exactly like this one then. Because there's nothing on the outside here to affect everything in there. That's a great question. Thank you. Sir? Now, okay. That's a whole different ball of wax, and we're going to get there. However, if there was out here, what? No. What would happen here is this gets distributed to this and to that. We're not there yet, but what it would be is now it would be x squared times y to the 4th. Or you could do this. X was 5 times 2 squared. Don't you have to do what's in parentheses first? So this is 5 times 4, which is 20. And then square it, and that'd be 400. Does that make sense, guys? Yes, sir. Talk to me, kid. 2 squared is 4. 4 times 5 is 20. Thank you, my brother. Thank you for caring. Okay. Next, x cubed, which is 4. So I want 4 cubed minus 2 times z, which is negative 2, times r, which is 7, over r squared, which is 7 squared, plus 2 times z, which is negative 2. I want to first do my numerator, okay? Complete that. So I've got 4 cubed, which is 64, minus 2 times negative 2 is a negative 2, times 7 is, negative 4. Negative 4 times 7 is negative 28. So that equals 64 plus 28, which equals 92. Okay, now we can work with the denominator. 7 squared is 49, plus 2 times negative 2, that's minus 4. So that's 45. So that's 45. And 92 45ths is 2 and 2 45ths. Very good, my brothers. Yes, sir. The subtraction sign, this one, my man, it is affecting it, Papa. Well, this negative got transferred here, right? And it's subtracting this multiplication value, correct? So I went minus on negative 28. And then that negative times negative becomes a positive. Thank you, my brother. Thank you very much. Okay, formula for trapezoid is A equals base 1 plus base 2 times height. This is used to find the area of a trapezoid. You should have learned that last year in geometry. Find the area of the given trapezoid. Guys, this is what a formula is. Before, those were just expressions. This is a formula. A formula is guaranteed forever, always. It's never going to change no matter what. No matter what, that is the area of a trapezoid. So we literally simply plug it in just like the expression and evaluate and find the value. So A equals base 1. You could call this or this base 1. It doesn't matter. I usually call the small base 1 to have consistency and the larger base 2. So base 1, which is 8, plus base 2, which is 10, times the height of 6 divided by 2. So now order of operations, gentlemen. I'm going to do my parentheses first. 8 plus 10 is 18 times 6 divided by 2. Now, In this particular case, now we're just dealing with fractions. Try to use your head, guys. You can multiply 18 times 6 and divide it by 2. That is fine by me. But wouldn't this be a lot more efficient? Take away a 2, take away a 2. 9 times 6 is 54. You were going to say that, weren't you, my brother? Awesome. Does that make sense, gentlemen? May I continue, gentlemen? Sir, my brother. Of course I could have taken away from the 6. Yes. Any combination. Thank you. But then you would have had 3 times 18. Not as many people can do that one in their head. I always try to go to the easiest route. Thank you, sir. I'm sorry, sir? No worries, man. Thank you, brother. All right. Another formula, guys. The number of gallons of gas that you put into your car is found by using the formula capital C divided by lowercase p equals lowercase n, where capital C is the total cost, lowercase p is the price per gallon, and lowercase n is the number of gallons. How many gallons of gas can you buy for $55 if gas costs $3.98 per gallon? Okay. Remember, we have C, P, and N. Plug into the appropriate location. Okay? The cost. What is the cost here in this example? What did they give you? $55. So that goes on my numerator. Okay? The total cost. Yeah. P is the price per gallon. What's the price per gallon here? $3.98. Absolutely. And then that's going to give me the number of gallons. Okay? Now, I'm going to use a calculator because I already have my degree. But you guys cannot use a calculator. And the number of gallons here will equal 13.819. Just for future reference, just so you guys know, I'm not going to make you go crazy far. Just go ahead and always round to the hundredths place. So this would be 13.82 gallons. Please always remember to label, guys. A lot of times people will put answers on their tests, like this one, for example, and they'll just put 13.82. Okay, that's great. 13.82 what? Dollars, gallons, cookies, cakes, basketballs, hats. What? You always have to define what for me, please. Yes, sir. Yes, I'm going to give you numbers like this constantly. Because on the SAT now, there's going to be a section without calculators. So I'm going to train you for success. Yes, sir. Give me 1 second, please. Okay, sorry about that, guys. All right. And then, of course, just like on the last page, guys, I need you to understand how to evaluate. So I added another CUDA software. Okay? And this one's called Evaluating Expressions. So you can practice. There's, again, a lot of practice here. Okay, a lot of questions. So if I were you and you're kind of lost or you just need some extra skill work, please go ahead and feel free to do extra work like this. And it has the answers, okay? And that is it for 1.1. Thank you very much. I hope you learned a lot and have a wonderful day. God bless you all.